Hi, it's Mr. Baker here. Today we're going to be looking at how we can make electricity. We're going to be looking at the generator effect. So today we're going to be looking at the generator effect. We're going to answer this question: how can we make AC electricity? Okay, so we're going to look at how we can generate electricity then. So here I've got a magnet that's inside a solenoid, and the ends of the solenoid are connected to a milliammeter or a galvanometer, something that will detect really small electric currents. So let's have a look what happens when I move the magnet around. So when I move the magnet inside the coil, inside the solenoid, you can see that I'm making electric current. My milliammeter, the needle there, is slightly moving because I'm moving this magnet around inside this coil. Okay, so I can make more electric current if I move it faster. If I move it slower, I don't make as much. So you can increase the amount of electric current generated by increasing the speed of the magnet through it. So that's one thing we can do. And let's have a look at what's actually happening inside the coil. So these little blue blobs with the minus symbols, these are electrons. And so when I move the magnet, you can see that the electrons move. And they move in different direction depending on the direction that I move my magnet. Okay, so when I move it to the right, you can see the electrons moving around in one direction. When I move it to the left, they're moving in the other direction, and that's why the needle either moves to the left or to the right. So if I move it to the right, you can see the electrons moving around in that direction. When I move it to the left, the electrons move in the opposite direction. So by changing the direction that the magnet is moving, we can change the direction of the electric current that we induce. Okay, so we found out two things. The speed changes the electric current, and the direction that we move the magnet changes the electric current. The other thing we could do is we could flip the polarity of the magnet. So now I've got my north pole on the right hand side, and you can see that when I move it in this direction now, the electric current is moving in the opposite direction. And so by changing the direction of the magnetic field, I can change the direction of the electric current as well. So let's have a look at what's going on then. So you might get asked to answer a question something like, how do you make an electric current flow in a conductor? So when the magnet moves in one direction, a potential difference is induced across the coil. In a complete circuit, current will then flow. When the magnet moves in the opposite direction, the potential difference is induced in the opposite direction, so the current flows in the opposite direction. The faster the magnet is moved, the larger the meter reading. When the bar magnet does not move, there is zero potential difference induced, and so zero current flows. The size of the induced potential difference increases when the speed of the movement increases, the strength of the magnetic field increases, the number of turns on the coil increases, or the area of the coil is greater. So in 3 and 4, what you're doing is you're increasing the amount of wire basically that is in the magnetic field. So for there to be more induced potential difference when the area of the coil is greater, the magnetic field has got to be strong enough so that the field lines will cross the loops of the conductor. So what should you be able to do by the end of today then? You should be able to state that electric current can be produced by wires and magnets moving, be able to describe the components of an electric generator and the process of electromagnetic induction in a wire. You should be able to identify the factors that affect the size of an induced current in a wire and the direction of current induced in a solenoid, and you should be able to explain why relative movement of a wire through a magnetic field is required to cause induction. Okay, so we asked at the beginning then, how can we make AC electricity? Remember, AC means alternating current. Okay, so when we've got a magnet moving inside a solenoid, we'll induce a potential difference. And if that solenoid is part of a complete circuit, it will induce a current. What we've seen is that if we move the magnet in different directions, we'll induce a potential difference in opposite directions. So by doing this repeatedly, we'd be able to induce an alternating potential difference. What would a graph of potential difference against time look like for this generator then? So we've got time on the x-axis and voltage on the y-axis. You might want to have a little sketch of it before we give it a go. So what do you think? So it would look something like this. It would look kind of like a sine curve going up and down or down and up like this, with potential difference being positive, then negative, with a constant frequency, a constant time period on the x-axis. Okay, so that's been all about the generator effect and how to make electricity. I've been Mr. Baker, this has been another physics video, and I'll see you next time. Thanks very much.